Assalamu alaikum dear students. Welcome to online classes initiated by Nasra Public School. Chemical Combinations, Grade 9, Chemistry, Lecture 2, Part 1. So let's have a quick recap of your previous lesson. Elements combine to form compounds. You can see elements in your periodic table. There would be carbon, nitrogen, oxygen, chlorine. These all are elements. These elements combine to form compounds. What is compound? Compound is made up of two or more than two different kinds of elements when two different elements join together. Law of conservation of mass was stated by Lavoisier. Law of conservation of mass was verified by Landolt. Conclusion of the law of conservation of mass is the mass of reactant is always equal to the mass of product. Law of definite proportion was stated by Lewis. Compound from any source always contains the same elements combined together in the same proportion by mass. Today's students' learning outcomes will be the law of multiple proportion and the law of reciprocal proportion. So first we will discuss law of multiple proportion. This law was given by John Dalton in 1803. Let's have a look on the statement of this law. It states that when two elements combine with each other to form two or more compounds, the ratios of the masses of one element that combines with the fixed mass of the other are simple whole numbers. Now in this law, we are going to deal with two different elements, and these two elements are going to combine with each other to form two compounds. As you already know that compounds are formed when two different elements join together. Now the most important part is that out of these two elements, the masses of one element is same or fixed during the formation of two different compounds. However, the mass of another element is changed or different. So the ratios of the masses of that element whose mass is not fixed or is different are in simple small whole numbers. Now try to understand the law of multiple proportion with the help of an example. Here you can see two different elements, carbon having a chemical symbol C and oxygen having a symbol O. These two elements are combined together to form two compounds. Firstly, they form carbon monoxide CO and then carbon dioxide CO2. These two compounds are formed by the same elements carbon and oxygen, but still they are different. As you can see, in carbon monoxide there is only single atom of oxygen, while in carbon dioxide there are two atoms of oxygen. Now we will focus on the masses of these two elements. So during the formation of carbon monoxide, only one atom of carbon and one oxygen are joined together. So the masses for both carbon and oxygen elements are written underneath the symbols. For carbon, it is 12 gram and for oxygen, it is 16 gram. You can also see the masses of these elements in your periodic table. So if you take a piece of carbon, it contains millions of carbon atoms. So what would be the mass of single carbon atom? It would be 12 gram. So 12 gram is the mass for single carbon atom. Similarly, the mass of single oxygen atom is 16 gram. And in carbon monoxide, there is only one atom of both carbon and oxygen. So these masses will be written as same. However, in the formation of carbon dioxide, there is only one carbon atom but 2 atoms of oxygen. You already know the masses of one oxygen atom, that is 16 gram. So the mass of 2 oxygen atoms will be double of 16, that is 32 gram. Since we have 2 oxygen atoms here, so the mass of oxygen will get doubled. Here you can see, out of these two compounds, carbon is the element that has a fixed mass, that is 12 gram, during the formation of both compounds. But the mass of oxygen is changed or different. So now we will focus on the ratio of masses of that element that has different masses. And here in this example, it is oxygen. Different masses of oxygen are 16:32. So the simplest or reduced ratio of 16:32 would be 1:2. So how would you get this simplest ratio? Just by dividing these masses by 16. So 16 ones are 16 and 16 twos are 32. So ratio of oxygen in these two compounds would be 1:2, which is simple small whole number ratio. If it had 5:9, so it wouldn't be small whole number ratio. But here it is 1:2, which is whole number ratio. So moving on this, let's have a look on another example. Here again you have two elements, hydrogen and oxygen, and they combine with each other to form water and hydrogen peroxide as well. So the mass of one hydrogen atom is 1 gram. Since here in the water we have 2 atoms of hydrogen, so the masses of hydrogen will be double, that is 2 gram. And here for oxygen there is only one atom and the mass for single oxygen atom is 16 gram. During the formation of hydrogen peroxide, there are again 2 atoms of hydrogen, but now we have 2 atoms of oxygen as well. So the mass of hydrogen will remain same, but the mass of oxygen will be double and becomes 32 gram. So again we have different masses of oxygen, 16:32, and their simplest ratio is 1:2. 16 ones are 16 and 16 twos are 32, which is a small whole number ratio. This lecture is to be continued. See part 2 of the lecture. Thank you.